All right, so what we want to do is we want to create our video for the test corrections. This is lesson check 3.2. The first problem is checking for converse, inverse, contrapositive, and basically what we need to do is identify the hypothesis. So this is P, the hypothesis. Two angles are supplementary. Then one angle will be obtuse. And this is our conclusion. So our propositional variable is P then Q, and we want to assess is it true or false. So when I look at the statement, I'm talking about supplementary angles, and you guys all know that those are angles that add up to 180. So we have a couple situations. We have a linear pair, and when we have a linear pair, one of these will be obtuse. We will also have where we have two separate angles. So like if this is 120 and this is 60, these are supplementary, and we have one obtuse angle. So we have to think of, are there any situations here where we'll have supplementary angles and we won't have an obtuse angle? And the only situation that I can think of is where we have uh, uh, a linear pair with one angle that's 90 degrees. And so these are what we call congruent supplementary angles. And this makes our conditional false, and this is our counterexample. So we know this statement here will be false. Now, the next thing we want to do is we have to use the P and the Q to come up with the propositional variable. Uh, we know that Q then P, so we want to make this statement match Q then P, and so basically it's just switching these two items in order. So it would be if one angle will be obtuse, then two angles are supplementary. Now we could probably write some better English here, but really all I'm trying to get is the switching of the hypothesis and conclusion, and as long as you do that, I'm good with that. Uh, we need to assess truth value. So it says if one angle will be obtuse, so we know obtuse is greater than 90. So if I have a 100-degree angle, then two angles are supplementary. So if I have another angle over here and it's 80, well, that's definitely supplementary, but is every angle going to be 80? So that's not the case, because you could have a 30-degree angle. So now 130 aren't supplementary. So this statement is false. All right, looking at the inverse. The inverse is negating the hypothesis, then negating the conclusion. So we would say if two angles are not supplementary, not supplementary, then one angle will not be obtuse. Will not be obtuse. So this statement, um, I know that if the converse is false, I know the inverse is false. And I personally like remembering this because sometimes the inverse can get really wordy with the knots, and switching. So if you know what the converse is, then you know what the inverse is. All right, the contrapositive is where we negate the conclusion, then negate the hypothesis. So we're basically negating the converse statement. And so we would get something like if one angle is not obtuse, then the two angles are not supplementary. All right, and the only thing left on this is truth value. And we know that if this statement up here is false, which we did, then we know the contrapositive is false. And again, I always like this logically equivalent business because this is an easier statement to assess truth value than this one with the knots and switching the hypothesis and conclusion. All right, next question is we want to look at, we want to sketch a figure to illustrate the given conditional. And so it says if a figure is triangle ABC, so this is the hypothesis, that's our P, and this is our conclusion. And what we learned is the hypothesis is the given statement, the conclusion is the proof statement. So this would be triangle ABC, and this would be the sum of all interior angles is 180 degrees. And the diagram looks like this: A, B, C. All right, moving on to the next question. The next question had to do with find the measure of each angle and identify the postulate, definition, or theorem that helps determine the angle's measure. So the first thing is we always start with this given information. So they tell us that the measure of angle MCA is 123. So the first bit of information is the given. From here, we know this is 123. And so that is because they are vertical angles. And then we know this angle is 57 because these two angles are a linear pair and they add up to 180, and so you can get that by taking 180 minus 123, which is 57. So we used a linear pair. All right, so from here, there's no other information I can use. I can't use this, so I can come to CBD, and I know that CBD is 109. And again, I know if this is 109, these two angles are a linear pair, and this is going to add up to 71. So you take 180 minus 109, which is 71. So now the last thing we want to do is we want to figure out what this angle here is. And so we can find this angle by using the triangle sum theorem. Sum theorem. And we know that if I add these together, I get 128. And then if I subtract that from 180, I get 52. So this angle in here will be 52. All right, next question. All right, so on this back page, what we want to do is we are solving for x, and we're using theorems to do that. So as you look at this, we see that this is an exterior angle, and we learned that the exterior angles equal the two remote interior angles. Interior angles. So this is the exterior angle theorem, and so we know that 100 equals 14x plus 6x. So that's 100 equals 20x, and then x equals 5. And that is our answer. All right, in this problem, we want to order the sides from largest to smallest. Well, 72 is the largest angle, so here's 72. So what's opposite 72 is going to be the longest side. So these are the angles, and this is the sides. So that would be segment ED. And then I ask myself, what's the next largest? That would be 70. What is opposite 70? That would be EC. So segment EC. And then what's the next largest would be 38, which is the smallest. And so CD would be the smallest side. Again, I have no idea what it equals, but because it's opposite the smallest angle, I know it has to be the smallest side. All right, so I'm getting the next problem. In this problem, we want to uh, state, can these make a triangle? So you can make a little sketch, 3, 6, 10. And what we learned is that the two sides of a triangle have to be bigger than the third side. And so when you take 3 plus 6, is that greater than 10? And we get 9 is greater than 10. This is not a true statement. So if this is not a true statement, these cannot be the sides of a triangle. So that would be no. All right, in this problem, uh, two sides of a triangle have the following measure. Find the range of possible measures for the third side. I have the triangle 12, 8. This is my third side, x. And so with the problem I did before, I know that these two sides have to be greater than the third side. So 12 plus x is great. Oops, no. Let's look at 12 plus 8 has to be greater than x. And so 12 plus 8 is 20, greater than x. Then let's look at 8 plus x is greater than 12. 8 plus x is greater than 12, so x is greater than 4 because we are subtracting by 8 on both sides. And then the last one would be x plus 12 is greater than 8. And then when you do the math here, we get x is greater than negative 4. But can this ever be a negative measurement? So we kind of disregard this. And we know that x is going to be less than 20 and greater than 4. All right. Just trying to get to the next problem here. All right, so now in this problem, we are two parallel lines we got a transversal. And so these are my angles. They're on alternate sides inside. So these are alternate interior angles. And we know they're equal, so 9x minus 3 equals 7x plus 11. Subtract 7x, you get 2x minus 3 equals 11. Add 3, you get 2x equals 14. X equals 7. Okay, again, in this problem, we have two parallel lines. Uh, the two angles are on the same side, but they're in corresponding spots. So we say they're corresponding angles. Corresponding angles. So then we get 80 equals 9x minus 10. And so then I add 10 to both sides and I get 90 equals 9x and x equals 10. Alright, next problem. Okay, in this problem we see that these angles are on the same side of the parallel lines. This is the transversal, so we know this is same-sided interior angles. And we know that 8x plus 7 plus 7x plus 8 equals 180. 8x plus 7x is 15x. 7 plus 8 is plus 15 equals 180. 15x equals 165. And then I want to divide 15. 165 divided by 15. So 15 goes into 16 once. So that's 1. Bring down the 5. So 15 goes into 15 once. So x equals 11. So in this problem, again, parallel lines, transversals. We're on alternate sides of the transversal. They're exterior, they're outside the parallel lines. So this is alternate exterior angles. And we know that they are equal, so x plus 130 equals 125. So x equals minus 130 minus 130 is minus 5. In this problem, we can see that we have a linear pair, and so we say it's a linear pair. And we know that a linear pair adds up to 180. So we have x plus 66 plus 125 equals 180. So x plus 191 equals 180. And if you subtract 191 from both sides, you get x equals negative 11. All right. In this problem, when you look at it, these are vertical angles, and so we get 37x plus 4 equals 115. So you subtract 4 on both sides, and you get 37x equals 111. And then you divide by 37 on both sides, and you get x is 3. And that's your answer. All right, as we look at this problem here, we can see that we have three angles that add up to 180. So we have 3x plus 4 plus 50 plus 90 equals 180. And then we can add this all together. But something that we can see real quick, guys, is if I subtract 90 from both sides, and I do that at the very beginning, 3x plus 4 plus 50 equals 90, we know that these two angles right here have to add up to 90. So then we do a little math here. So 3x plus 54 equals 90. And then 3x, you subtract 54 and you get 36. And then you divide by 3 and x equals 12. And now we are ready. Oh, for this problem here. In this problem, it says in each exercise, some information is given. Use this information to name the transversal. Okay, so we're naming the transversal, the angle relationship, and segments that must be parallel if possible. If there are no such segments, write none. So we have angle 2 and angle 9. I told you guys to put a dot on the vertex and then to draw a line connecting the two dots of the angles. Since we have two dots here that we can connect, the transversal is segment BF. When I also told you to take and highlight the angle, so you have angle 2 here and then you have angle 9 here. And this is the transversal. The angles are on alternate sides. So we would say these are alternate interior angles. And if you do the squiggly lines right, highlighting the angles, you know this side is parallel to this side. So that would be segment AB is parallel to segment FC. And that's your answer. All right, so now here we are at the last problem, the extra credit problems. We want to simplify the square root of 54, so we look at the factors, which are 1 times 54, 2 times 18. No, not 2 times 18, that's 2 times 27. And then 3, it goes into that once, and that's 18. And then 4 doesn't go into it, 5 doesn't go into it, 6 and 9. So when we look at the factors, we see a factor of 9. So this is the same thing as the square root of 9 times the square root of 6. And so this simplifies to 3 square root 6. And that's our answer. In B, we want to find what x is. We look at this triangle. It's a right triangle. It's a 45, 45, 90 triangle. So I know this is the hypotenuse. This is the leg. And we know that the hypotenuse is equal to the leg times root 2. If I know that the hypotenuse is 5 root 2 equals x times root 2, then I divide by root 2, divide by root 2. The root 2's cancel, and so I get 5 equals x. So x and y, x equals y equals 5 is my answer. All right, this concludes my tutorial. I hope it's helpful and hope it helps for the test tomorrow. Thank you very much.